guys, today we are going to see about matrix multiplication. Okay, what is matrix multiplication? We already know about scalar multiplication. That is, we are going to multiply a constant number k with one matrix. This is scalar multiplication. Here two inputs, one is singular, that is a singular value, and another one is a matrix, right? But in a matrix multiplication, by both the input is going to be a matrix A and B. Okay. For A and B for a multiplication, there is some condition. That is, the number of columns of A. Note this, guys, right? Guys, this number of column of A must be equal to the number of rows of B. That is, if A is having a dimension of 1 by 3 and B is having a dimension of 3 by 1, then only it is possible. That is, the number of column, that is here R by C, here R by C, and this C should always equal to this R. Then only matrix multiplication is possible. And after that, what is the remaining R here? 1. What is remaining B here? 1. That will be the dimension of my new matrix. See here, the dimension of the matrix need not to be equal as addition, but the number of column of the A matrix and number of rows of the B matrix should be equal for multiplying any two matrix. Okay, I will explain very more clear. That is, if I am having a matrix 1, 2, 3, 4, what is the dimension of this? 2 by 2. Okay, what is the matrix B? I am taking as minus 1, 3, 4, 5. What is the dimension of this? 2 by 2. Now, number of row in A column. Number of column in A matrix. What is that? 2. Number of rows in the B matrix. What is that? 2. Since these two are equal, then now we can able to multiply A and B. And what is the resultant matrix is going to be, and what is remaining left out? That is row of A by column of B. Okay, so this is how it is going to be. Okay, so now think, guys, whether we can able to multiply this kind of matrix, that is matrix B with 2 by 1 and matrix A with 4 by 2. Not possible, right? Because number of column in the A matrix and number of row in the B matrix is not equal. So multiplication of this B cross A is not possible. Similarly here, it is 2 here and it is 6. Whether it is possible? No, not possible. But here it is possible because A is 2 by 3 and B is 3 by 2, and number of column in the A matrix and number of row in the B matrix are equal. So what is the remaining thing? 2. So that is going to be my resultant. Okay. So just like that, we can't multiply any two matrix. The matrix should be in this condition. Okay. Now, how we are going to multiply? So guys, see that this A matrix is in the form of 2 by 3, and this B matrix is in the form of 3 by 2. That's why it is possible. And see, now this 3 by 3 can left out, and what will be the remaining? 2 by 3, 2 by 2. So that will be my resultant matrix. Okay, how to form C11? So I am going to take now this as A is equal to 1, 2, 3, 4, and B is equal to 1, 3. Whether we can able to multiply this matrix? For that, I want to write the dimensions. This is 2 by 2 matrix. This is 1 by 2 matrix. So it is not possible to multiply these two, right? You want to write not possible. Okay. So now I am taking A matrix as 1, 2, 3 and B matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? What is the dimension of A? This is 1 by 3. And what is the dimension of B? 3 by 3. Whether it is possible, number of column in the first matrix and number of row in the second matrix are equal. So we can able to multiply, and my resultant matrix is going to be in the order of 1 by 3. Okay, what is my AB is going to be is, so as I said, put arrow mark. This will give you some idea. That is, I am going to take the row of A and column of B. So 1 into 1 is going to be 1 into 1 plus now second into this second value. So 2 into 4, then this third value into this third value, plus 3 into 7. Guys, are you understanding this? Okay. So now this is going to be the second row. So this is going to be the second row. This one into this one. So 1 into 2 plus 2 into 5 plus 8 into 3. So 3 into 8, both are same. Then 1 into 3 plus 2 into 6 plus 3 into 9. So what is going to be my AB value is going to be 1 plus 8 plus 21 and 2 plus 10 plus 24. So 3 plus 12 plus 27 is going to be equal to 30. So this is going to be my AB matrix. Okay. So this is what we already noted. And remember this thing, guys, here identity matrix in any matrix will give me the same matrix, that is 1 0 into 0 1. If you multiply with like 1 in the normal number system, if I multiply 1 0 with 0 1 with any matrix, I will get the same matrix. You also try this once and the same. So here matrix multiplication is not commutative. What it means, that is ES will be not equal to ST. That is, now I multiplied these two, I got the value of 3, 15, 20, but ST value is 23, 6, 10, 0, which is both not are equal. So it's not commutative. The matrix multiplication is not a commutative. The next is transpose of the matrix. What is the meaning of transpose? Here, transpose is converting the rows into columns. If I'm having a matrix like this, and now what I did, this is rows, right? And this row, now I converted into a column. 2, 4, 7, we are written in column. First row will become a first column and second row will become a second column. So this is known as transpose of a matrix. So A matrix transpose will be expressed as A to the power of T. So that is T for transpose. That is A transpose can take, this is one of the important operations. A transpose, we can take A transpose like A is equal to 1, 2, 3, 4. Then my A transpose will be equal to my first row will become my first column. That is 1, 2, and similarly 3, 4 can be written here 3, 4. So this is known as transpose of a matrix. Using the transpose, what will happen is the dimension of a matrix will change. So dimension of a matrix 2 cross 3 will change into 3 cross 2. That is, here I add a matrix of 2, 4, 7, 5, 3, 1. That is 2 rows and 3 columns. After transposing, how it changed is number of column became 2 and number of row became 3. Okay. So these are some properties of transpose. So how it is going to be, I am going to check this another 4 properties. You guys has to do another 3. I will do the first one. See what it said, A plus B transpose will be equal to A transpose plus B transpose, right? So for this, what I'm doing, I will take my property first. A plus B transpose will be equal to A transpose plus B transpose. So I will take A matrix as 1, 2, 3, 4, 5, 6, and B matrix as 1, 2, 1, 2, 1, 4. Okay. So what will be my A plus B? is going to be 2, 4, 4, 6, 6, 10. And what is going to be A plus B transpose? So I already told. So transpose means my rows will become column and columns will become row. So my row, that is 2, 4, 4 is going to be my first column here. Similarly 6, 6, 10. So I will take this as number 1. Similarly, what is A transpose here? A transpose is going to be 1, 4, 2, 5, 3, 6. Similarly, B transpose is going to be 1, 2, 2, 1, 1, 4. Now what is going to be A transpose plus B transpose? That is 2, 6, 4, 6, 4, 10. From this is 2. From 1 and 2 what we are concluding? From 1 and 2, A plus B transpose is equal to A transpose plus B transpose. So similarly guys, you also try another 3 properties what we have. Okay, so these 3 property you take it as an assignment.